Hey guys, welcome back. Today we're going to talk a little bit about properties of congruence. Yesterday we talked about properties of equality, and we talked about how we can use those properties as justifications for doing algebraic proofs. We're going to try to take a step into the geometric realm today and do some proofs that still have some algebra in them, but that start kind of in geometry land, or with a shape, or with a geometry statement, and end with a geometry statement. So we're going to talk about segments in particular. We're going to do the same thing with angles in our next lesson, but we're going to just kind of stick to segments today. What I wanted to show you here is that there's less properties of congruence than there are properties of equality. And we're going to do some examples over here with segments in just a second. But these are the properties of equality that we talked about, things we can do when we have equations and we have numbers and things like that. We got our addition subtraction property of equality, our multiplication and division property of equality. We talked about those. Then we have substitution, transitive, reflexive, and symmetric. Okay. Notice that the properties of congruence, we don't have as many. We don't have these same properties of congruence. We only have transitive, reflexive, and symmetric. So these are similar, and we're going to kind of go through what these look like over here on this side just so you can get an example of what that looks like. So we're going to use this as a reference, this diagram here. So we got some segments here, A, B, B, C, and C, D, and they all kind of, we put them together and we get this whole big segment. And over here, I'm going to write some congruence statements, and over here, I'm going to write some equality statements, and we're going to talk about what we can do on the congruent side and what we can do on the equality side. So let's talk about transitive for a minute, okay? Transitive property of congruence works very similar to the transitive property of equality. But let's do it with a segment to see if we can kind of figure out what that would look like. For equality, we would say something like, if A equals B and B equals C, then A equals C. Okay, but we're not talking about numbers, we're talking about segments when we're talking about congruence here. So we're going to say something like, if AB, the segment, right, we put a line over it, is congruent to BC, the segment, and BC, the segment, is congruent to CD, the segment, then what? Well, let's see if we can break this down for a minute. AB is congruent to BC. Okay, cool. But BC is congruent to CD. What does that mean then? Well, that means that these two guys have to be congruent to each other. If this is congruent to this guy and this is congruent to this guy, then these two have to be congruent. So we can kind of jump over the middle guy and we can say then AB, our first segment, is congruent to CD, our last segment. So that's transitive property. That's how the transitive property would look in if we're talking about congruence and we're talking about segments. Okay, so that's transitive. Switch colors here so we can tell the difference. Let's talk about what reflexive will look like. Okay, over here, reflexives is just anything is equal to itself. So we could say like A equals A, right? Anything is symmetric to itself. So over here, anything is equal to itself. That's the reflexive property. Over here, we can say that any segment is congruent to itself. So we can say AB is going to be congruent to AB. We can do that. We can also kind of do something really similar to this, but just change the order. Now this isn't a property of congruence, this is just how we write segments. AB and BA, those are the same segments, right? Those are equivalent. Doesn't really matter where I start and stop because we have endpoints here. Okay, so one of the things I can do, and we're actually going to use this later on in proof, so it's good to know that we can do this. We can say AB is congruent to BA, right? That's the same thing as this, right? AB is congruent to itself. Sometimes that's helpful, and this kind of looks like almost like the symmetric property where you're changing the order, but we're not switching stuff on either side of the congruence. We're just changing the order of the letters, and again, that's not a property of congruence. That's at work when we flip those. That's just how we know how to write segments. Okay, so that's kind of how the reflexive property works. Let's take a look at symmetric here. So for symmetric, This is where we can change the order of what's on either side. So if I had something like this, AB is congruent to CD, I can swap that. I can turn it around and say CD is congruent to AB. Okay, so notice the difference on like what I did here versus what I did here. Here, all I did was change the order of the letters, and again, that has nothing to do with the property of congruence. That's just how we write segments. We're allowed to kind of reverse those. These are equivalent segments, not because of a property of congruence, but just how we write segments. The main thing is showing that with reflexive is that showing a segment is congruent to itself. That's what's happening here. What's happening here is the segments on either side of the congruent symbol are actually switching to the opposite sides, so we can do that as well when we say two things are congruent. Now what we have to keep in mind is that congruence always refers to a shape. In this case, we're talking about a segment. Later, we're going to be talking about angles, and then later we're going to be talking about triangles. So congruence always refers to a shape being like the same size as something else. It's kind of like equality, but two shapes aren't equal, they're congruent. The measurements of the shapes can be equal. And so in just a second, we're going to come back and we're actually going to look at some of the properties of equality that we can use with segment measurement.